Okay, so for this problem, we know that theta equals 22 degrees and the coefficient of friction is 0.12. So first, I drew the free body diagram, and the x-axis is the slope that the carton is traveling on, and there, as you can see, there's a 22-degree angle. The forces acting on it are the normal force going up, the friction force pointing to the left, and the force of gravity going straight down. So there's the two components, the y and x components. From looking at the equation, net forces of y equals may, we see that it equates to Fn minus mgy equals 0, so therefore Fn equals mgy. Also, Fx equals max, so with the forces, the force of gravity in the x component minus the force of friction equals max. Looking at the top right of the screen, you can tell that I found that the force of friction equals 0.12 mgy by doing some substitution. I then divided both sides of the equation by the mass, which cancels it out. So we're left with 9.8 sine 22 minus 9.8 times 0.12 times cosine of 22 equals a. And after plugging it into your calculator, you get that acceleration equals 2.58 meters per second squared. For part B, we have to find the final velocity when the carton reaches the bottom of the slope. It's still a 22-degree angle, except this time it's starting from 9.3 meters up. So we're going to be using a kinematics equation, Vf squared equals Vi squared plus 2a delta d. So when you plug in, we're looking for Vf squared, so the initial velocity is 0, the acceleration is still 2.58, and the delta d is 9.3 meters. And when you plug that into your calculator, you get Vf squared equals 47.988, or Vf equals 6.93 meters per second, and that's your final velocity.